If 1 squared minus t1 plus 2 squared minus t2 all the way till n squared minus tn is equals to n into n squared minus 1 upon 3, then tn is equal to 5. So you got that the summation from 1 squared to n squared will be fine. That has to be n into n plus 1 into 2n plus 1 upon 6, and then minus t1 plus t2 plus, okay, all the way till tn. So summation from 1 to n of ti, right, that has to be equal to n into n squared minus 1 upon 3. That gives me that the summation from 1 to n of ti, that has to be this thing minus this thing. Okay, cool. Which I think I can factorize it. So like n into n plus 1 upon 6 into, first of all, you got 2n plus 1, then you have an n minus 1 over there, but 2 times of that thing, so 2n minus 2. Yeah, that looks correct, right? So upon 3, that would give me 6. Wait, it's supposed to be negative of that, in fact. So negative of that, so that has to be n into n plus 1 upon 6, and then over here this cancels, you got 3 over there, so like that has to be 2 in that case. So n into n plus 1 upon 2. Okay, cool. So that's nice, which means that fine. So your summation is equal to n into n plus 1 upon 2. So from that I can say that Tn is equal to the summation from 1 to n minus the summation from 1 to n minus 1 of Ti. That will just be n into n plus 1 upon 2 minus n minus 1 into n upon 2, right? Which has to be, well, you got n common, so n plus 1 minus, I mean n by 2 common, so n plus 1 minus n minus 1, that's 2. So this is just n. So Tn is the same thing as n. Okay, cool. Then Tn is equal to, wait, n squared minus, I, something went wrong. Okay, let's just do it once again. Yeah, cool. So what did we just do? I think n into n plus 1 into 2n plus 1 upon 6 minus of n into n minus 1 into n plus 1 upon 3, that has to be equal to the summation of Ti from I equals to 1 to n. So the summation from I equals to 1 to n of Ti, that has to be, let's see what we get, n into n plus 1 upon 6 into 2n minus 1 minus of n minus 1, but 2 times of that, so like minus 2n, minus minus is just plus, so plus 2 over there. Oh yeah, we did make some kind of mistake. So n into n plus 1 upon 6, over here this cancels, so I just have 1 over there. No, wait, it is supposed to be 2n plus 1, right? So in fact this is like 3, so n into n plus 1 upon 2 looks correct. So in that case Tn has to be n, right? So it has to be like n, but okay, so options do not contain n, so it should be none of these in that case. uh okay, that is weird. So n into n minus 1 upon 3, let's just check it out. So n into n plus 1 into 2n plus 1 upon 6 minus n into n plus 1 upon 2, that has to be n into n plus 1 upon 6 into 2n plus 1 minus of 3. Okay, cool. So that's just minus 2, so that has to be n into n squared minus 1 upon 3. That is exactly what we got over there. So yes, Tn has to be n, but okay, it's not over there, so none of these should be the correct answer. Okay, cool, let's move on. So this is like none of these. Fine. Let the positive numbers a, b, c and d be in an ap, then a, b, c, a, b, d, a, c, d and b, c, d are, okay, so a, b, c are positive numbers, a, b, c, d are positive numbers in ap, then these are in. Fine. So I think I'll just divide this thing by ABCD. Okay, cool. So you got that these are in a AP, and I think that these are going to be in a harmonic progression, because we know that 1 upon A, 1 upon B, and 1 upon C and 1 upon D, that these numbers are in a harmonic progression. That pretty much means that if I multiply these terms by ABCD, that will give me, yes, that will give me BCD, and then ACD, and then ABD, and ABC. Okay, that tells me that these numbers are also in a harmonic progression, right? Cool. Fine. I mean, no problem. It's just this series, but I mean, like, in reverse order. Okay, cool. So let's move on. So this is in harmonic progression. Fine. The sum of the first n terms of the series 1 by 2 plus 3 by 4 plus 7 by 8 plus 15 by 16, okay, till n terms, is equal to, well, 1 by 2 is just 1 minus 1 by 2, and then 3 by 4 is just 1 minus 1 by 4, 7 by 8, that's just 1 minus 1 by 8, and it is like going till n terms, so 1 minus 1 upon 2 power n, that has to be n minus half, and then you got 1 minus half raised to the nth power upon 1 minus half. Okay, cool, which is just half itself, like that cancels, so it has to be n minus 1 plus 1 by 2 raised to the nth power. Okay, so that's actually n plus 2 to the negative n power minus 1, which is this thing. Okay, let's move on. Suppose that f of n plus 1, okay, you have a recursion over there, so f of n plus 1 is equals to 2 times of f of n plus 1 upon 2 for n equals to 1 2 3 so on, and f of 1 equals to 2, then f of 101 equals, okay, first of all I want to point out that 2 into f of n plus 1 is equals to 2 into f of n, or in other word, I mean plus 1, or in other words, f of n plus 1 is equals to f of n plus 1 by 2, which means that in fact this series will be in a arithmetic progression. Okay, cool. And we know that the first term is 2, the difference is 1 by 2, the first term is 2. Just want to find f of 101, so f of 101, that will be 2 plus 101 is giving me 100 into the difference, which is 1 by 2 over there, which is 2 plus 50, which is 52. Cool, so 52 is the answer. Let's move on. Okay, cool. So the next question is, if 1 minus p into, what's this thing, into 1 plus 3x plus 9x squared plus 27x cubed plus 81x power 4 plus 235x to the okay, I need to point out that 3 9 27, these are actually powers of 3. Fine. And this is equal to 1 minus p power 6. Okay, let's just do it. So 1 minus p into this thing. Okay, cool. So 1 plus, wait a second, the value of p upon x is, okay, cool. So 1 plus 3x plus 3x squared plus 3x cubed all the way till 3x raised to the 5th power. This is just 1 minus p into 3x raised to the 6th power minus 1 upon, in fact I should write it in the opposite way. So 1 minus 3x raised to the 6th power upon 1 minus 3x. Okay, that has to be equal to 1 minus p power 6. So 1 minus 3x raised to the 6th power upon 1 minus 3x has to be 1 minus p power 6 upon 1 minus p, and this looks like 3x should be equal to p. We are given that p is not equal, okay, fine, so p is not equal to 1 is just to make this defined, nothing else. Then the value of p upon x is, I think that it should be 3, right? Yeah, it should be 3 because like that is in fact a solution, right? So p equals to 3x, that could be a solution of this equation. So it's like a sixth degree equation, more like a fifth degree equation in fact. Whatever, so just by guessing I think a 3 will work. Okay, cool, let's move on. So the next question is the sum of three numbers in GP is 14. If one is added to the first and second and one is subtracted from the third, the new numbers are in AP. The smallest of them is. Okay, cool. So suppose you have these numbers A, AR and AR squared, and the sum is 14. Okay, cool. If one is added to the first, so you got A plus 1, then and second, okay, so AR plus 1, and 1 is subtracted from the third, AR squared minus 1. The new numbers are in AP, the smallest of them is. So 2AR plus 2 is equals to their sum, which is AR plus AR squared. Nice. That gives me 2 into AR plus 1 is equals to A into, wait, that doesn't work. That doesn't work. Fine, so these are in fact in the AP, so 2AR plus 2 equals to, why did I erase that? Okay, whatever. AR square plus A. Fine. Now what? So now you have this equation and that equation. What we want to find is the smallest of these numbers. Fine. So wait, you know that A plus AR squared happens over there as well. We know that A plus AR squared is just 14 minus AR. So let's just input that thing over here. So 14 minus AR. So that gives me 3AR is equal to 12. So AR has to be 4. So now we know what the middle term is. Okay, cool. So that's like 4. So this is going to be 4 upon R. So you got 4 upon R, and 4 into R. Fine. That has to be equal to 14. And these are in a, okay, fine, we used those equations to get this thing. So we have no need for those anymore. Okay, cool. Right. So we know that the middle term is 4. And from this equation itself, we will get the value of R. So this gives me 2 upon R, plus 2 plus 2R is equals to 7. So multiply by R, that will give me 2 plus 2R plus 2R squared is equals to 7. So 2R squared plus 2R minus 5 has to be equal to 0. Right. But now what? Now we are kind of stuck because 2 into 5 will, how can we break that to get 2? I don't think we can. Oh, this is supposed to be equal to 7R over there. That's why this equation turned out to be very unsolvable. So 2R squared minus 5R plus 2 equals to 0. That is in fact solvable. So 2R squared minus 4R minus R plus 2 equals to 0. So R minus 2 into 2R minus 1 equals to 0. So R equals to 2 or 1 by 2. And both of them give the same set of answers. Right, I mean the same set of those three numbers. Yeah, so the ratio is 2 or 1 by 2. So this 4 upon 2, that will be 2. And then this is like 4 into 2, which is 8. So the smallest of them is just 2. Cool, let's move on. Smallest of them is 2. Right, let us see what other things we can do. Oh, so the options are over here. Fine. If p plus qth term of a GP is A and its p minus qth term is B, where A and B are positive real numbers, then its pth term is, okay, so the p plus qth term of a GP is A and the p minus qth term is B. So yeah, looks correct. So like A upon B, A upon, sorry, A upon B, not B. That will be, you got, okay, that will be R raised to the p plus q minus of p minus q power. Right, that looks correct because the difference is that thing. So that times, you get the idea, fine. So that is going to be 2q, I think. Yeah, that looks correct. That has to be 2q. uh, Wait, but we want to find the pth term, right? The pth term will be in fact, uh, okay, their geometric mean in that case. So in that case the pth term will be square root of ab. No problem, right? So look at that, a sub p minus q, then a sub p and a sub p plus q. From this thing to that thing you have a jump of r power q. From here to here you once again have a jump of r power q. So these are also in a gp. That means that ap, I mean a sub p, that has to be the geometric mean of a and b. So it has to be square root of ab, because these numbers are all positive. Okay, so 37th question is, if a1 a2 a3, where a1 is greater than 0, are three successive terms of a gp with common ratio r, the value of r for which a3 is greater than 4a2 minus 3a1 holds is given by. Okay, cool. So these are three successive terms of a gp with common ratio r, and you are given this inequality. Okay, so let's just input the values like this. So a3, I will say it's ar squared, where a is the same thing as a1, and that gives me ar squared is greater than 4ar minus 3a. And the first term is greater than 0, so we can just cancel that without changing the inequality or anything. So r squared has to be greater than r minus 3. So r squared minus r plus 3 has to be, wait, 4 over there. Okay, so minus 4r plus 3 has to be greater than 0. So r minus 1 into r minus 3 has to be greater than 0. Now you can draw the number line 1 3, plus minus plus. Over here this value is positive, over here this value is this value is positive, here this value is negative. So we just take this thing, right? We take this interval and this interval. So r belongs to negative infinity to 1 union, I think that's correct, so 3 to infinity. In other words, r is greater than 3 or r is less than 1. Okay, cool. Let's move on. Okay, so the next question is, if 1 minus 1 upon 3 plus 1 upon 5 minus 1 upon 7 plus 1 upon 9, okay, this keeps on going, is pi by 4, then the value of, what's this thing, then the value of 1 upon 1 into 3 plus 1 upon 5 into 7. So you can see the difference is actually just 2. So this thing, it can be written as half of, well, 2 can be written as 3 minus 1. So this is 1 upon 1 minus 1 upon 3, plus 1 upon 5 minus 1 upon 7. It keeps going like that. Okay, cool. So this is just pi by 4. Yeah, but half of that, that's supposed to be pi by 8. So that's a fairly short question. Okay, so that's enough for one video. I will see you in the next one.